All right, guys, welcome back. This is week 32. This should be Tuesday for you. This week we're going to look at line graphs and linear equalities in more detail. We're going to do it with example problems. We're going to start by talking about the independent and the dependent variable. Okay, I wrote them here. The independent variable is the one thing that just keeps going, independent of everything else. Think about what the word independent means. The dependent variable depends on whatever happens with the independent variable. The independent variable very often is time. Time keeps marching on, right? So if a plant's growing over time, the plant's height depends on time. So independent variable. There is an acronym that can help you with this. It's called dry mix. You may have learned this in science class. Dry mix. The dependent is the responding variable, and it's on the y-axis. We're not going to worry about the R in math. The independent variable is the manipulated variable, and it's on the x-axis. So this part is independent of this. Okay, so let's look at this. So the table below shows how the monthly payment for a life insurance policy depends on the age of the person insured. So the age of the person insured, that's the time. That's independent. Someone just keeps going up and up in years, right? And what depends on that, how much money they get every month. So this is the independent variable, the age. And what depends on the age, how much money they get, monthly payment in dollars. Okay, so that's how you do that one. Okay, the next one. Yoko is a runner. The graph below shows how the number of training miles she runs affects the time it takes her to finish a race. Okay, so the number of training miles she runs affects her time to finish the race. So the time to finish the race isn't like the time here. That's dependent on how much she trains. Okay, so the training miles is the independent variable, which is always on the x-axis. Dry mix. Number of training miles is independent. And what depends on that training miles? That's how much time it takes her to finish. Okay, so that's your independent and dependent variables. Okay, let's move on. The next question. The graph below shows the number of visitors at a museum over 6 days. Okay, so now we're just working on reading line graphs. So anytime it's trending up, sloping upwards, we know the number of visitors is increasing. Anytime it slopes down, we know it's decreasing. So what was the greatest number of visitors in one day? We're not going to look at how it's trending. We're just going to look at the highest number of visitors, which would be here on Sunday. Next, when did the number of visitors have the greatest decrease? So when is it sloping down the fastest? This is the lowest number, but looking at the slope of that, that's not the biggest decrease. Here's the biggest decrease between days. So between Sunday and Monday. Sunday to Monday. Okay, let's look at another one like this. What was the least donation amount in a month? So we're looking at the smallest donation amount. This is the independent. The days keep rolling on, the months keep rolling on. The donation amount depends on the month. So the least was right here, September. When did the greatest increase in donations occur? So the biggest uptick. So here's an increase, here's an increase. The bigger increase, not the biggest amount, is right here between September and October. So to October. All right, so that's reading and interpreting line graphs. Okay, this next skill is helpful for tomorrow's assignment. So I do want you to get used to making T-charts. And with T-charts, we're going to put the independent variable over on this side and then the dependent over on this. This is going to help us make those line graphs because, like we said, then we'll have both data points. We'll have the independent and then the dependent. Kind of like what we did with ordered pairs earlier in the year. Okay, so a construction crew is lengthening a road that originally was 54 miles. The crew is adding 1 mile to the road each day. The length in miles after D days of construction is given by the following formula, or L equals 54 plus D. Okay, so which is independent, the days or the miles? That's right, the days. The days keep marching on. So then the dependent variable would be the miles. Okay. So after 0 days, well, it's already 54 miles. After 1 day, it added 1 mile. It's 55 miles. After 2 days, it's 56. After 3 days, 57. So this is how we can make a T-chart with this information. How long is it after 22 days? Well, after 22, it's 22 plus 54, which is 76. We could plug that into the equation to get that quicker, but I want us to understand the why for tomorrow. If you don't do this today, tomorrow's is going to be that much more difficult. Okay, let's look at another one like that. Carlos tutors math. For each hour that he tutors, he earns $30. His earnings in dollars after tutoring H hours is given by this formula. Earnings equals 30 times H hours. So my independent variable is how many hours. What depends on the hours? How much money he's making, his earnings in E. So after 0 hours, he doesn't make any money. After 1 hour, he makes $30. After 2 hours, he makes 60. After 3 hours, he makes 90. Knowing this is going to help us make our equation tomorrow. Today we're given that equation. Tomorrow you're going to have to make that based on the T-chart. Okay, so how much does he make after 5 hours? I could just keep going and adding 30 each time. But a shortcut for repeated addition is multiplication. So we're going to do 5 times 30, $150. All right, again, let's make sure we understand the why behind this. Okay, question 7. Each year, Bill drives 5,000 miles. Hey, look, they already made a T-chart for us. Use this information to fill in the table or a T-chart, then plot the ordered pairs by the table. Okay, so this is the number of years on this side. This is the independent variable. What depends on the number of years is the distance in miles. So after 1 year, he'd go 5,000. After 2 years, he goes 10,000. After 3 years, it'd be 15. After 4, it'd be 4 times 5,000, 20,000 miles. And so you could figure out the formula for this. This times this is this. 5,000 times this is this. 5,000 times 9 is 45,000. Okay, so that's kind of like our T-charts that we made back up here. Okay, so now we can just graph these 3 points. Over 2, up 10,000. Over 4, up 20,000. Over 9, up 45,000. Okay, so the skill we're going to work on tomorrow with this is turning this into a line graph then. So then we'll connect our dots. And it will even go through the point 0, 0 here, won't it? Because he wouldn't have driven any. Okay, so there we go. In Alex, you only have to make 2 points and then connect your dots because it's a linear equation. It's going to keep going with that same slope. This isn't like our earlier interpretation questions. Okay, let's do another one like this. Last one. Okay, let's look at question 8 now. Brian earns $30 for each hour that he works. So if we were to make a T-chart with this, hours is my independent variable. And then the money he earns is going to be dependent on that. Okay, so after 0 hours, he would have made $0. 1 hour, $30. 2 hours, 60. We can do repeated addition or we can do multiplication as a shortcut. And again, we're working on this skill today because tomorrow we're going to actually write those equations. So, number of hours worked. He worked 2 hours. Well, we said 2 times 30 would give you $60. After 4 hours, 4 times 30 is $120. After 5 hours, 5 30s. 5 times 30 is $150. So, there's my graph. It's the same stuff I have over here in my T-chart. So now I can just add these to my line graph down here. I can just plot these points. Over 2, up 60. Over 4 hours, up 120, where they intersect. Over 5, up to 150. I could even put a point at 0, 0. Okay, now they should form an exact straight line with the slope being somewhere all the way up. All right, that's your assignment today. It'll get you ready for tomorrow. Good luck on it.